Hi everyone, welcome to YourPedia. And as you know that we are in IIT Ropar campus for the academic profiling. And today I am in structural analysis lab, and with me, Mr. Vipin Kumar, who is a senior lab assistant. Welcome, Vipin sir. First of all, tell me about yourself.
Welcome. Thank you. Myself, Vipin Kumar. I am here, senior lab assistant, and this is the structural engineering lab. Oh, this lab is very important lab on civil engineering, so I can enter in lab. And this lab, we are dealing different type of structure of their component. In this lab, we have some model of structural engineering lab. I will show you different type of model we have in this lab, like two-inch charge. This is a two-inch charge apparatus, and this is pin joint truss apparatus and three-inch charge. And
Okay.
you can see in this area, some students are working on the experiment of unsymmetrical bending movement, and there are some students working. So I will hand over to Mr. Siddharth. He will explain about the unsymmetrical bending movement.
Yes. So now this experiment is on how to determine the unsymmetrical bending. This is a L section. So we have to just place the load, and we have to. This is the dial gauge, and in dial gauge we have to note down the reading when we apply the load. So when we apply the load, the dial gauge will rotate, and number of readings multiplied by the least count will give you the displacement. On the other end, this is the dial gauge on which the degrees are written. So we need to know the how much it has rotated, means how much it has unsymmetrical. This section is unsymmetrical. Like the symmetrical section we have is the I section, in which the load is passed through the principal plane. But in case of unsymmetrical section, the load will not to pass through the principal plane, and it will try to rotate on its axis. And we have to, and if the load is passing through the means if the load is passing through the principal plane, then there will not be twisting. But if load is not passing, then it will twist, and we have to know the point where the load, such that we apply a load and it won't twist. So that point is the shear center. So in that case, first we have to apply the load. So please put the load here. And now you have to note down the dial gauge reading. So one is the, now this is the vertical deflection which is there. So in we need to note down the deflection at every 200 grams. So again you put 200 grams. One by one you put. Now note down the readings, how much it has rotated. So your vertical deflection is given by P L cube cos theta. This is the cantilever beam. So the deflection is PL cube by 3EI. So PL cube cos theta. Theta you will get from here. The degree, how much it has rotated. See, it has rotated 90 degree. So 90 degree cos 90 divided by 3 IUU. IU is the moment of inertia about UU axis. Okay. Now this is L section. Now you can use channel also. Now L section, the shear center will pass through the junction of the flange in the web.
And what about the channel section, sir?
Channel section, it will pass away from the flange section. So it is the outside of the section.
It will lies outside.
But how you know that the channel section it is away, but how you will apply the load? It is away, so either you have to you can weld a plate and then you apply the load, means from not from the section. But in case of L section, you can apply a load here like this, so it won't twist. So that is the concept of shear center. In channel section, as the shear center is away, so you need some arrangement. In that arrangement, some plate, gusset plate, or you need some arrangement such that it passes away from the section. So from there you can apply the load. This is L section. You can for zigzag section also, Z section also, you can do the same procedure. Okay. Any more question?
Sir, in this, we only use vertical deflection.
We can
Only
measure.
vertical deflection.
Yes, here the arrangement we have kept is the for the vertical deflection, but in horizontal deflection also we can
How
measure.
can we measure that, sir?
You need to just place a dial gauge here. So when you apply load, it will the load will transfer here, and the dial gauge will give reading vertical as well as horizontal. So you need to place one dial gauge also.
Okay.
And in case of horizontal deflection, the sine theta you have to replace by cos theta.
Okay.
Everything is same, so you will get both the deflection. Now noting the you have to note down the load and the deflection and the angle.
Angle.
So you will get the how much unsymmetrical deflection the section has undergone.
Okay, sir. Okay. Okay, so अभी आपने जो बताया, first of all, introduce yourself. You
Sir,
are
my name is Siddharth, and I am a PhD scholar, final year student. I am working under Dr. Muthulingam Subramanian, and I am working on corrosion and fatigue of reinforcing a steel bar under fire condition. So I am in the final year, and I am also taking the TA for the MTech students and BTech student. Yeah.
okay. So thank you, sir, for giving us a time.
Thank you for
Okay,
your
sir.
coming here and taking some give me
Okay.
opportunity.
So thank you.
well.